next thing we'll probably want to do whenever we have an absolute value function is to understand how to find the rule. Before we start that, we actually need to understand what the rule looks like. So right here we have our general format for an absolute value function. Before we start solving for our rule, I'm going to talk about our parameters here and the effect that they have. So this value of a, you should have seen the last video that the slope of the two lines that make up our absolute value function, they have a slope of negative a and positive a. So what does that mean for our graph? Well, we know that value of a out in the front can make our graph wider or more steep. Okay, we can also have, if we have a negative value of a, we can also have a graph that is upside down. And again, more steep or open wider. So that value of a out in the front will affect the orientation of our graph, whether it's facing upwards or whether it's flipped upside down. And it will also affect the rate at which the y values are increasing as we move over in x. Our next parameter here is h. It's the exact same as every other h parameter, so it takes our graph and it moves it right or left. And we know that from before. We also know that it's a subtract h, so that if we have x plus 3, for example, that would mean that our h value is negative. Our last parameter is k, and again it's the same as our other parameters from previous functions and from our chapter on parameters. The value of k moves our graph up or down. And we'll use that later on whenever we are trying to do questions that require us to interpret from a graph. We need to be able to understand what happens as we change these parameters within our function. All right, so let's take a look at some rules here that help us find the rule of our function. And it's very, very similar to the square root function. So the very first thing is that we need to find the coordinates of the vertex and another point on the curve, or they could be given to us. So we need to know our vertex and at least one other point on our curve. The next thing that we're going to do, again, same as our square root function, we're going to substitute the coordinates of the vertex for h and k. If you watched the last video, we know that the coordinate of that vertex is h and k. And our other value for x and for y. And from there, we should be able to solve to find the parameter a. Now, when we're doing that, we have to make sure we're applying those properties, those rules that we talked about in our last video. So there's a reason why I gave those to us. Let's take a look at an example where we'll be able to apply these steps. All right. So our example says, find the rule of a square root function that has a vertex located at negative 4 and 3 and passes through the point negative 3 and 0. So the first thing that we want to do is just remind ourselves of the format of a square root function. And remind ourselves again of what we're going to substitute in. So this is my vertex, negative 4 and 3. So I'm going to be replacing h and k with negative 4 and 3. And I didn't think this out very well because I didn't leave myself very much space. Let's just, whoa! Oh my gosh, it's just like being in my classroom where I'm moving stuff around when I shouldn't be. All right, and we're going to replace x and y in our equation with that. So my value of y is 0 is equal to a times the absolute value of my x being negative 3, subtract my h, which is a negative 4, plus k, which is 3. From there, I'm going to subtract a 3 on both sides, and I end up with negative 3 is equal to a times the absolute value of, this becomes negative 3 plus 4, which just gives us 1. The absolute value of 1 is just 1, so I have my value of a equal to negative 3, and we know that we have to write our final answer here, so I'll switch back to another color. Our final answer is that y is equal to negative 3 times the absolute value of x plus 4 plus 3. And what does that look like based on the parameters that we see here? First of all, our value of a is negative. Okay, so we know that our graph will be flipped upside down. We also know that that value of 3 means that it will be vertically stretched. So A being -3 means it's flipped upside down and that it has a vertical stretch by a factor of 3. The +4 means that our h value is actually negative. It's a -4, so our graph will be moved to the left 4 spaces. And that +3 means it will be moved up 3 spaces. So we should have a pretty good picture in our head of what this graph would look like.